So we've gone through the various forms of an amplifier, a voltage amplifier, current amplifier, transconductance amplifier, and transresistance amplifier. And it might all seem kind of weird and strange, and why do we got to do all that stuff? And this is a transresistance amplifier, but honestly, it's the same as any other amplifier. We can look at it in various ways. If we want to define this amplifier, then we need to find if we wanted to solve it, we need to find the value of Rm, and we need to know Ri and Rout of the amplifier. And then given those values for a voltage source and a load, we can figure out all the currents and voltages. Well, so what is a transistor resistance amplifier? What is this current source? I mean, why do we have to deal with that? Well, that could be some kind of weak signal source, like a photodiode, for instance. A forward biased one would have actually a very strong current and a very large change in current for changes in light, but a very small change in voltage. And so we might really want to consider that as a signal source, which is a current source, not a voltage source. Even though, of course, a voltage running through a resistance gives you, or a current running through a resistance gives you a voltage. So we could build this as an op-amp circuit. So this is our signal source. We've got 0.5 milliamps, and we've got a 10K signal resistance. And if we feed an op-amp, let's put minus and plus there, and we've got, should have left myself a little more room, I guess. Let's put the ground over here. In the inverting configuration. That's what I look like. And would this be a trans resistance amplifier? Well, I think it is. Let's label a little bit more here. We've got we'll give that 10K, and I'm not going to worry about the load. And we've got V out right here. And is this goofy thing really a transresistance amplifier, or why can't we just convert it to a Thevenin equivalent that we know and recognize, right? So you know that circuit, that's the inverting configuration, and why can't we just solve it that way? And reality is you could convert that voltage, that current source, to a Thevenin source and solve this circuit exactly with this circuit down here. It would work perfectly fine. But I'm asking you to find this abstract model where we have Rm, because really if this was, say, some current source like a photodiode, it really does make a current, and we really want to find how it amplifies that current into a voltage, which of course is what a op-amp will do. So one of the points of these different models of an amplifier is that it's easier to solve the amplifier if you use the one that's natural for it. And I think that the transresistance amplifier is the natural way to solve this circuit. Now, whenever you look at an op-amp circuit, if you see negative resistance, oops, I didn't want to do that. If you see negative resistance in a path like this back to the inverting input, that means you've got a virtual short between the input and the output, between that non-inverting input and the non-inverting input. So we have that V minus is equal to V plus, is equal to 0 volts. We got V plus here, and I got V minus there. And that means if we've got 0 volts over here, and we've got 0 volts over here, then we have 0 amps flowing through that signal generator's source, that source resistance RS. We have no current flowing in there because we've got ground on both sides of that. Is this useless? Is this dumb? Is that stupid? Well, this current source here will ideally output exactly 0.5 milliamp. That's its job. That's what it does. It's going to send 0.5 milliamp out there, and we have 0 milliamps flowing down through there. So that means that all of that 0.5 milliamp wants to be flowing that way, right? It's just flowing straight on. And a current source is perfectly happy to have 0 volts on both sides of it. It doesn't care. An ideal current source will create any voltage across it that it needs to achieve that 0.5 milliamp current. And as this current from the current source is going on this way, it's going through this feedback resistor, this 10K resistor here. And that's affecting the output of that op amp. So one thing that you can see right off the bat is that from that statement I just made here, so R in is what the this signal generator, which is a current source, sees looking into the amplifier, and that means R in is looking in there. Well, it's 0. So Rn is 0 ohms. It's an ideal situation for this op amp, and it's for this signal generator. And actually, we already know that since this is a voltage source on the output of the op amp, that its output resistance is 0 ohms. So R in and R out equals 0, and that's exactly what we need for a trans-resistance amplifier. That's what's needed. So an op amp achieves that with negative feedback, of course. So then what's V out? V minus is equal to 0. Minus 0, just 0. And we can find that current, I2, the current flowing in the 10K. I2 is equal to 0.5 milliamps. It's also equal to II. And so that's 0.5 milliamps. That's the current flowing in, because there's 0 current flowing in here. So that means that II has to be perfectly equal to 0.5. And this would be equal to V minus V out over R2. That's R2, right? That feedback resistor. And V minus is equal to 0. We'll go with black. So we've just got I2 is equal to minus V out over R2, or we could say that V out is equal to minus I2 times that feedback resistor, R2. So that would be equal to 0.5 milliamps and 10K, which is equal to minus 5 volts. And then, so we got minus 5 volts there. And then we'd like to have the value of Rm. Well, Rm, that value on the voltage source that you multiply by the input current II to get a voltage output is just the output voltage V out over II, and that's minus 5 over 5 milliamps, which is equal to minus 10K volts per amp. And we always use volts per amp as the units, not ohms or inverse ohms, minus 10K volts per amp. This way of thinking about the op-amp circuit, it's exactly what we would have done if we had that Thevenin equivalent on the input voltage source, but it's easier to find this abstract model of the amplifier if we think about it in terms of the current source on the input. And with that abstract model, there's all kinds of things that we can do simply and easily. So a transresistance amplifier, we can perfectly make it from an op-amp, and using negative feedback. You don't have to think about an op-amp as only being used with a Thevenin voltage input. It could be a Norton current. I'm not expecting to have any my open math exercises here, so that's probably all. But if there is one that shows up, please do it.